Greetings, my fellow humanoid dwellers. Today we're going to talk about resistors. In order to measure a resistance, you have to use a multimeter, and I've positioned one right here. I have it. If I click on it, it brings up here. I'm going to use it to measure resistance. We're going to use the top and the bottom. If you remember, all these points are connected together, but they're separate from the ones down here, where these are all connected together. So we're going to connect this meter to line 20, because now we've connected this row with this row, and this meter is in this row. We're going to do the same thing at the bottom, but in order to go across this right here, we have to run a line down to here, and then we have to run a line across to here. I've selected 3 different values of resistor: 100, 1000, and 10,000. Don't worry too much about what that means or what these lines mean. We'll go over that in another class. If I drag this resistor over to here and hit the simulate button, you'll see that it says 100. And this symbol means ohm, 100 ohms. If I stop the simulation and put the 1000 in here, start the simulation, just goes to 1000, or whenever you see the K means 1000. So 1K, or 1000 ohms. The final one we're going to look at is this one, and this is a 10,000 ohm, or 10K. Start the simulation, 10K. And the question is what happens if we put these in a row? So we're going to stop the simulation. Move it over to here. We're going to take the 1K, and we're going to rotate it. If you go up here, you can rotate components. Just needs to move over one more. So now we have a path that goes down to here, through this resistor, and down to here. So let's increase this. Okay, let's delete this. Delete. And draw a new line. And now we have a path. Over, down, over, down, over, up. So we start the simulation. This is 10, and this is 1K, or 10,000 and 1,000. So what do you expect? 11,000. You add them together. Now the next question is, what happens if you put these in parallel or right next to each other? Stop the simulation. Let's put this back over to here. Let's take this, go back and rotate it. Put it right next to it here. Line these together. These together. Drag that back. Now the path goes through here, down, both of these together. So through both of these at the same time. Do you expect to see 11,000 again? This is something else for a further class. But whenever you have resistors that are in parallel, connected together like this, it is always less than the lowest value. The lowest value here is 1,000, and this is 900 ohms, or 0.9K. let me stop the simulation and replace this 1000 with this 100. And you should expect to see something less than 100. 99 ohms, which is just a little less than 100. Now what's interesting is you can see that it's very close to 100, but it is less than 100. So what happens if we replace this 10,000 with this 1,000? It's even less than that. And there are math equations that you can do to calculate what that will be. And we'll go over that later also. The other thing you might notice is that this resistor is upside down from this resistor. Resistors do not matter. They do not have what's called polarity. They don't have a positive and a negative. You can turn them whichever way you want. If we stop the simulation and flip this one all the way around, start the simulation, you'll see that you get the same value. And just remember that in parallel, it's always less than the least valued resistor. The other thing is, in a simulator like this, the values are always perfect. In the real world, they're not. I'm going to cut now to a video where I'm measuring some resistance of actual resistors, and you'll see that the values are not exactly what they say they'll be. I'm going to use a 100 ohm, a 1000 ohm, and a 10,000 ohm, or a 100, 1K, and 10K ohm resistor. I'm going to use 2 meters for this next resistor test. The blue one is a higher quality one that I've had for a while. The red one is one I ordered off Amazon for $10, including shipping. It'll be one I'll recommend that you purchase if you just want a cheap meter to do some measurements. If you notice on the red one it says 9.86. I have a 10K ohm resistor in place right now. And I'll switch it over to the blue one and see if we get close to 9.86. And we get 9.87. So you can see the 10K doesn't come out to exactly 10K like it did in the simulator, but it's fairly close. You'll also notice that the blue meter will auto scale, so it'll automatically adjust. I'm switching the meter out now, or the resistor out now, for a 1K ohm. The blue one is reading a very precise, the red one will also read 1K. The red one's reading right on. Now I'm swapping it out for the 100 ohm resistor. The red one stays on the K scale, and instead of reading 0.1K, it's reading 0.09. Now the blue one auto-scaled, so it reads ohms now. Instead of reading 100 ohms, it's reading 99.97. Okay, now I'm going to go ahead and put 2 in series, a 1K ohm and a 10K ohm. I would expect to get 11K, just like we did in the experiment. We don't get exactly 11K, we get 10.8K, and that's the difference between real-world resistors and simulator resistors. The red one's reading 10.87 also. Now I'm going to switch them and put them in parallel. Expect to get less than 1K. 0.9 is less than 1K. I'm going to go to the blue one. I would expect to see about 900 ohms. 914 ohms, or 0.914K. This is a picture of the meter that I used in this experiment. It only costs $10 including shipping from Amazon. I'll provide a link to it where you're seeing this video. If I'm unable to provide a link where you're seeing the video, it will be available on cheapcontrols.com. By using this link, you help support the site. Thanks for watching.